Hello everybody, today we're gonna revise for physics because we have an exam in 2 days. Yeah, so let's get straight into it. In the first question, it says, in the particle model, how is a moving object represented in a motion diagram? So everybody is familiar with the particle model. So everybody knows that it's a series of single points, because when you bring an example, so look, like imagine you draw a box with a point and then it has more points in front of it. So it shows that it's moving. And the more space between the points, it means the more speed. And the less space, less speed. So if you want to represent an object is moving by a motion diagram, it's gonna be a series of single points, and it's gonna be like faded or something like that, so it shows that it's moving. Yeah, that's it. So one is B. The length of the displacement vector represents how far an object can be thrown, or is visible, or traveled in one direction, or can be stretched. Feel free to pause the video so you can just answer the question. So, displacement vector means that displacement is the shortest distance between 2 points. So you're gonna be measuring the distance traveled in one direction. That's the closest answer. So because it says is visible in B, that's stupid. And A is can be thrown, everything can be thrown, and D can be stretched. These are all like obvious. That is wrong. So C is the answer. Let me just draw it. Yup. And here, forgot to do it. Yeah, that's it. Now you go down. What information can you obtain from a position time graph? So position time graph is the opposite of motion diagram. A position time graph, it's like it shows pictures instead of series of single points. So in the position time graph, like you can imagine a car. I don't know how to draw. Imagine a car moving. It's gonna show like maybe it shows an arrow. I don't know how to draw an arrow, bro. Like that. And then cars, like the car is moving. Shows you that the car moving. Yeah. So you see, like here. See the distance? I was going slower. Yup. I don't know how to draw an iPad. Alright. Just delete all this. I'm just trying to be like the organic chemistry tutor, but teaching physics. I never see him teach physics, so I'm gonna do it instead. So let's go back to the question. What information can you obtain from a position time graph about an object's motion and interactions? So, of course, like you're not gonna find the magnitude. And of course you're not gonna find the time interval. That's another type of time graph, and gravity is just stupid. So, closest answer is D, because you're gonna find how it's moving. You're gonna find its positions easily because it's gonna distribute the pictures. Yeah, let's go to question 4. Which of the following best defines instantaneous acceleration? So if you guys are not familiar with instantaneous acceleration, it just means that like the object at a single point of time is gonna like move. It's gonna accelerate from a single point to like a random speed that it gives you. So like its acceleration, it's not specific time because it's instantaneous. Instantaneous means instant. Everybody knows what instant means. So yeah, single point is the closest answer. So plus B, and C is the average change in velocity over time. No, that's another formula for another question. So yeah, total change in displacement divided by time. No, that's not the thing. Alright, let's go down. So here, look, a displacement vector has its tail at the origin of a coordinate system and forms a 60-degree angle with the positive x-axis. What is the x component of the vector? So let me give you some examples. So if instead of x it said y will go with the let me remember. Yeah, x is in cosine, and y is with sine. You have to remember this. It's gonna be very important because we have the final exam in 2 days. So yeah, y is sine and x is cos. And if you want to know what tangent is, it's basically like it's not real. It doesn't like exist. So yeah, what is the x component of the vector? So imagine you drew a graph and 60-degree angle. Wait, 60-degree angle. Yup, 60 and x, y. So if it says what is the x component, it's gonna be one of these two because these are placed wrong. This one's the up is supposed to be cosequent, I think, but yeah, the answer is one of these, cos. So because x, it wants to find out what x component is. All right, hope you understand that. Let's go down. Yeah, this one's easy, and it's been stuck in my head since the first of semester. So yeah, first one, another term given for a size of quantity. So another term given for the size of quantity is magnitude. All right. B, a quantity with both direction and magnitude. Everybody's familiar with this, so it's vector because vector has magnitude and direction. And the opposite of magnitude, opposite of vector is not opposite, but it has one missing direction. It has direction missing. It's a scale. D is scale. And lastly, a vector that represents the sum of two. The sum of two or more, it means result. It's trying to find a result. Yeah, that's it. So it goes like that. That's it. Let's go down. What does displacement refer to? As I said in like the second question, I think, displacement refers to the shortest distance between the starting and ending point. I'm sorry that I said like 2 points. I meant the starting and ending point, like here and here. So this is an example of like not displacement. It goes like all around this. For displacement, I can change the color like that. That's the shortest distance. That's the displacement. All right. What is the formula for calculating speed? Speed is, I don't know how, I think this is speed. All right. It's distance over distance over time. Yeah. So which one is distance over time? This one is wrong. If you're gonna put this one, is wrong because this is time over distance. Distance is supposed to be up top and time is supposed to be down, so like that. Yeah. So answer is D. Now, A 5 kilogram object is subjected to a net force of 20 newtons. What is the acceleration of the object? So this question is very similar to Newton's second law of motion. His second law of motion says that force is equals, what happened? Oh no. Here. Force is equal to mass times acceleration. That's Newton's second law, which is shown right here. I'm not gonna go through that question now, but let's finish this one first. So, what is given? We have mass and we have force. And we're finding what? Acceleration. Since we don't have acceleration, we can use this formula, but in another way. So, we have mass as 5 and force as 20. And this one is unknown. So what we do with them, we just put it instead of putting F after the equal, just put A, and the F, just bring it under M. So it's gonna be A equals mass over force. And since we have mass 5, I'm gonna put right here. This is the formula if you want to find acceleration. Wait. Acceleration equals 5 over 20. 20. That's it. And you can do this in your head or in the calculator. It's okay. 5 divided by 20 is obviously 4. And you have to remember the unit, because all of them use this unit, meter per second square. So the acceleration is mass and meter per second square. That's the answer of acceleration. So B. Yup. No. Look, for every action, which of the following best explains Newton's second law of motion? So, as I said over here, Newton's second law of motion is product of mass times acceleration, which is equals to F. So, which one is most familiar and similar to the one up top? Feel free to pause the video. I'll be with you in a second. So, the answer is going to be B, because here it says product of mass and acceleration. So this is the second law. The B is the second law of Newton. And if you want to know the first and third law, the first law of Newton is objects at rest stay at rest until acted upon a force. So imagine a ball. This is for the first law. Imagine a ball on the grass and no one's touching it. It's at rest now. And imagine a guy, I don't know how to draw. Imagine a guy come run, and just shot the ball. So now it's not at rest, it's accelerating, going up. So that means that objects at rest stay at rest unless acted upon a force. This little guy is acting on the ball with the force of his legs. So yeah, this is the first law. And for the third law, for every action there is an equal and opposite reaction. So imagine 2 toy cars. That's a bus. Imagine 2 toy cars. What am I drawing? I'm sorry, I'm drawing on an iPad. Imagine this car is at 2 kilograms. of mass. And this one is also a 2 kilogram mass. And this guy is moving at an acceleration of 3 meters per second. Let me draw 3 meters per second. And this one is also 3 meters per second. So when they hit each other, this one is gonna go back 3 meters per second, and this one is also gonna go back at 3 meters per second. So yeah, that's the third law, and that's the first law. And for the second law, it's this one. Yeah, that's it. Let's go down. Moving faster as you pedal your bicycle harder on a level road demonstrates Newton's which law? Moving faster as you pedal your bike, pedal is accelerating. Harder on a level road. Level road means a road that's just straight. It's not going up, it's not going down. It's just straight. Yeah, imagine it's a bicycle. Yeah, I know how to drive a basketball. Alright? Now, if you're familiar with Newton's second law, it's the only law that describes or uses acceleration. So yeah, it's gonna be Newton's second law. Alright. When the drag force of an object equals the gravitational force the object attains, which one of these? So feel free to pause the video and try to do it yourself. So when the drag force of an object is equal to the gravitational force the object attains, either acceleration or terminal velocity. I'm gonna wait for you to answer down below in the comments. I'm joking, this video is not gonna go anywhere. It's just for me, and I'm just trying to revise with myself. So, as the question says, when the drag force of an object equals the gravitational force the object attains, and if you said B, terminal velocity, is correct. Yeah. Let's go down. The force of kinetic friction between a box sliding on the surface depends on which one. It's either the surface area, force causing the motion, normal force, speed of the box. The friction is how it slides on the ground. If it was ice, it would be sliding with almost no friction. And if it was on like a road, it would be sliding with a strong friction. If it was on glue, it would be impossible to slide. So the force of kinetic friction between a box sliding on the surface depends on the normal force. So the answer is C. The gravitational force between two masses become weaker when distance between the masses increase or decrease, or the product of mass increase, the gravitational constant changes. So the gravitational force is the force that pulls you from the surface to like the Earth's core, or where there's gravitational pull. And it becomes weaker when the distance increases. Like imagine two magnets. You know those magnets with two different colors? So I'm gonna use accurate representation like that. And this one. Like that. Stop texting. So yeah, when does the force become weaker? So look, I put the opposite so it can just stick to each other if it was close. So when does the gravitational force become weaker? Is it when it goes beside each other and they stick to each other, or when they go farther away from each other? The answer is A. Because when you put a magnet beside another magnet with the opposite uh, positive or negative, it's gonna pull it apart. It's gonna just pull it, and then they're gonna be apart. So yeah, when the masses distance between the masses increase, is the answer. Which of the following statement best defines impulse? So as you know, impulse is the product of the average force on an object and the time interval over which the force acts. So I don't have like a a simple example I can explain, but it'll be hard. So I'm just gonna give you the answer, and if you want to find the answer, maybe I'll post another video. I'm gonna continue the questions that I didn't do. I'm gonna just mark them with a highlighter. That's it. Let's go down. The graph describes the motion of an object moving east along a straight path. So east, if you're not familiar with the directions, this is north, this is east, this is west, this is south. Oh yeah. So east is Yamin. See, east is right, so it's going right. Yeah, so the graph describes the motion of an object moving. Imagine the blue line is an object. Yeah, moving east along the straight path. And this is the velocity, so it's the speed. And this is the time. And you have to remember that the unit is meters per minute, not per second, because here it gives you seconds. Yeah, so let's continue. During the first 300 seconds of travel, so approximately like right here, it traveled with a velocity of 30. So this one is the distance, this one is time. Yeah. So it traveled, just put 30, because this velocity is per meters per minute. So this is correct if you wanna like just put the answer quickly. So yeah, the first one is 30, and between 300 and 600. So about here. Between, as you can see, the line has stopped. It stayed at rest, and while this one is, the time is moving. So yeah, and the answer is 0, because you can see a straight line. And now between 600 and 900. So over here, from this one to this one. From this one to this one. Let me just do this. Do that. Do that. Yeah. I'm sorry, like I'm drawing a lot, but I just want to revise later, so that's why I'm drawing. So as you can see, it went down from 30 to 15. Yeah. So what's the answer when something is going like down on the opposite direction of positive? It becomes negative. And how much of negative did it go down? 15. So because 15 minus 30 is 15. So negative 15 meters per minute square. And between 1,200 until the end, it came down from 15 to 0. So I'm gonna just put the same. Yeah. That's it for this question. We are done from 6C. Now let's continue. So the net force, if you put like the blue one, blue, 40 Newton, and let me put 50. Why did I write the 0? 40, 50, 60, and 30. As you can see, it's going up by 10 between each colors. So look, and now the net force acting at a point is approximately, so I think I got the answer right. Let me just use my calculator. Like that, 80. I don't have like a simple example for this one, so I'm just gonna put the answers from the revision. Because I'm gonna go back to this in the second video, because it's gonna be like long. So now, 5 forces are acting on the object in the diagram. You have to like add up and just divide. So yeah, the 6th force, if you want to find the 6th force, the 6th force required for equilibrium is 31 newtons. That, so what's equilibrium? So equilibrium is 31.0 newtons. So it's about just 31, and at an angle of 277.7. That's the answer. Now, long answer question. This is the last 2 questions, I think. No, it's not. It's the last 2 questions in this paper. So yeah, analyze how Newton's 3rd law applies when a rocket launches into space. So Newton's 3rd law is, let's go back so you can be familiar with it. This one is 3rd law. For every action, there is an equal and opposite reaction. So let's go back to the question. For every action, there's an equal and opposite reaction. Describe the interaction between the rocket and the exhaust gases, and how this interaction results in motion. So, when the rocket launches into space, Newton's 2nd and 3rd law of motion explains its Newton's 2nd and 3rd law of motion explains its motion. According to Newton's 3rd law, yeah. According to Newton's 3rd law, the rocket pushes exhaust gases downward. Yeah, so the rocket pushes exhaust gases downward, so it moves up, and in response, the gases push the rockets upward with an equal and opposite force. Now, when you apply the Newton's second law, if the force equals mass times acceleration, describes how the rocket accelerates as its engines produce a constant force while its mass decreases as fuel burns. Yeah, so of course a rocket is gonna have it's gonna have fuel. So how would it move? Let's just draw a simple rocket. What the fuck? How do we draw a rocket? Like that. Imagine this is the exhaust. This one, the big one, is the exhaust, and this is the gases coming out. So if you want an example of Newton's third law, the rocket launches into space, describes the interaction between the rocket and the exhaust gases. So the rocket uses fuel, burns fuel, so gases are exited from the exhaust, and that results to movement of the rocket going upward into space. So yeah, and that's the third law applied. And how is this integral results in motion, and how it results in motion. The rocket accelerates as engines produce a constant force while its mass decreases, fuel burns. This decreasing mass allows the rocket to accelerate more. Yeah, so it's losing weight and accelerating the same speed, the same force. It's gonna move faster, so it's ascents. Together, these laws show how interaction between the rocket and exhaust gases result in an upward motion and increased velocity. Yeah, that's the answer for that question. Imagine a truck, for number 20, imagine a truck and a car are traveling on a highway. The truck has a mass of 5,000 kilograms and is accelerating at a speed of 2 meters per second square, while the car has a mass of 1,000 kilograms and accelerating at a 5 meters per second square speed. So yeah, I want to give the example. The truck, imagine the truck has a mass of 5,000. Yeah, and now we have to calculate each force exerted by each vehicle and the engine to produce the given acceleration. Yeah, so if you want to calculate the force exerted by each vehicle's engine to produce the given acceleration, it's gonna be 10,000 newtons, because 2 times 5,000 is 10,000 newtons. And now you want to compare the forces and explain how Newton's second law of motion, force equals mass times acceleration, justifies the difference in force required for the truck and the car. So yeah, the truck requires 10,000 newtons of force as said above, and while the car requires only 5,000 newtons, because 1,000 times 5 equals 5,000. So let me just distribute. The T is represented by truck, has 10,000 newtons, and car is 1 FT. So the force of truck, force of car, this one is 5,000. Yeah, and the truck requires only 10,000 newtons of force, while the car only requires 5,000 newtons of force. The reason for the difference because in Newton's second law, force, this one is force. If you want to find force, it's equals mass times acceleration. So acceleration for the truck is gonna be 2 meters per second, and the mass is gonna be 5,000. So 2 times 5,000 is gonna be 10,000 newtons. So that's the force of the truck. And simply, the car has 1,000 kilograms and accelerating at a 5 meter per second. Force times mass. Force equals mass times acceleration. So 1,000 times 5 is 5,000. So that's how you got 5,000 newtons in the force of the car. Yeah, and like the Newton's second law states that the force depends on both. What am I drawing? That force depends on both the mass and acceleration. So the truck has a much larger mass. It's approximately times 2 as from the car, and 5,000 kilograms compared to 1,000, which increase the required force even though the acceleration is smaller, because the truck has 2 meters per second square of acceleration and the car has 5. It's 2.5. This one is 2.5 more. 2 times 2.5 equals 5 meters per second. So the car has much faster acceleration, but even though the truck has times double its force. Yeah, so that's the comparison. And the car with a smaller mass required less force and achieve higher acceleration. Oh yeah, let's go down. So in mechanics, in 2 dimensions, the length of displacement vector represent how far an object. This one we already went through this question. So as we said, C traveled in one direction. Now a graphical representation of a displacement vector of a distance d has its tail at the origin of the coordinate system, making the angle an angle of 30 with the positive x-axis. So as we said, if you want to find the x component, x is gonna be cos, so d cos 30, and why 30? Because an angle of 30 is over here set. So d is the vector. Vector is d. So vector cosine 30 angle 30 degrees.